Hey, is your eye color protecting you right now, or is it secretly putting you at risk? Believe it or not, the answer is literally staring you in the face. If you want to catch these biological clues early and really understand how your body works, hit like and subscribe right now, because we decode the incredible secrets of human biology in these explainers every single week. You see, your eye color isn't just about looks. It's actually an ancient, highly evolved survival tool that our ancestors used to conquer the globe. Think about this. Over 70% of the human population globally has brown eyes. But what about that remaining 30%? Well, they're actually carrying ancient genetic mutations that tell a wild, global story of human migration, adaptation, and evolution. Your eyes are basically a living map of exactly where you came from. Okay, let's dive into this. To really understand how eye color protects you, we've got to talk about melanin. Think of it as nature's built-in SPF 1000, setting directly inside your iris. For early humans migrating across the intense sun-drenched African savanna, having this rich pigment wasn't just some cosmetic feature, right? It was absolutely crucial. It acted as an evolutionary shield, protecting vulnerable eye cells from brutal, DNA-damaging ultraviolet radiation. And honestly, it is incredibly effective. Research from the University of Copenhagen confirms that melanin is so dense, so efficient, that it absorbs up to 90% of the light entering the eye. Because it absorbs that light, rather than just letting it bounce around inside, it significantly reduces glare sensitivity, which means much sharper, clearer vision in intense daylight. Now, you might be wondering about black eyes. Well, functionally speaking, true black eyes don't actually exist. I know, crazy, right? What we perceive as black is really just an extreme, ultra-dense concentration of brown melanin. This heavy saturation makes them the absolute best at absorbing light, giving you maximum protection and visual stability in equatorial regions where harsh sun exposure is just a constant threat. Brown eyes still offer a massive biological shield for sure, but those with the deepest, darkest irises, they've got the ultimate UV filtering system. Now, what's really interesting about this next part is the story of blue eyes. It all comes down to a single, incredible glitch, the HERC2 mutation. Get this, if you have blue eyes, you share a direct link with every single other blue-eyed person on the planet. You all trace back to one single ancestor. This precise genetic mutation acted like a biological switch that literally turned off the ability to produce brown pigment in the iris. Boom. Suddenly, a brand new eye color was born. And this mutation spread like wildfire. It popped up roughly 10,000 years ago and then began moving into northern Europe by about 6,000 years ago during the Neolithic expansion from the Black Sea. Today, it has a massive 95% frequency in some of those northern regions. So why did it spread so incredibly fast? Well, researchers believe that having minimal melanin allowed more light to actually reach the retina, which would totally enhance vision during those long, dim northern winters. Plus, its striking rarity at the time likely gave it a huge boost through sexual selection. But here is the most mind-bending fact of all. There is absolutely zero blue pigment in a blue eye. None. Zero. Furthermore, ancient DNA analysis has completely debunked some old assumptions, proving that light eyes actually evolved well before humans developed pale skin adaptations. However, this lack of melanin, it comes with a pretty major cost. Blue eyes are highly vulnerable to UV damage over a person's lifetime. So if there's no blue pigment, why do they look blue? Well, it's an optical illusion driven by a structural physics trick called Tyndall scattering. Because there's almost no melanin to absorb the light, the shorter blue wavelengths hit the eye and scatter right back out, while the longer wavelengths pass straight through. It is literally the exact same light scattering physics that makes the sky appear blue on a clear day. How cool is that? Taking it a step further into rarity, we have gray eyes. These show up in completely distinct ways in under 3% of the population. Gray eyes have even less melanin than blue eyes. This creates a diffuse scattering effect across multiple light wavelengths, giving them this steely, neutral tone that kind of shifts with the light. While this might be an extreme adaptation for overcast skies, their near-total lack of melanin leaves them highly exposed and, unfortunately, terribly vulnerable to sun damage. Then we get to the rarest common eye color on Earth. Green eyes make up only 2% of the global population. The reason they are so incredibly uncommon is that they require a massive genetic lottery to win. Seriously, it takes a precise, perfectly balanced cocktail of at least 16 different genes interacting to create this exact hue. To get a green eye, you need a very, very narrow sweet spot. a moderate level of melanin combined with a specialized yellow pigment called lipochrome. But this delicate balance actually creates a chemically unstable structure. This is exactly why people with green eyes often notice their color dynamically shifting, going from a mossy shadow to golden green, depending entirely on the clothing they wear or the lighting they're standing in at that moment. And this brilliantly illustrates our next group, hazel eyes. Seen in about 5% of people, they are the ultimate evolutionary chameleons. Sitting right smack in the middle of the melanin spectrum, they offer a highly adaptable biological blend. They give you moderate UV protection while retaining excellent light sensitivity. That makes them a perfect evolutionary response from mixed environments and changing seasonal climates. Now, it's pretty easy to confuse hazel with amber, but the biology under the hood is vastly different. While hazel shifts wildly based on light and surroundings because of its mixed melanin distribution, amber eyes contain high lipochrome but almost zero melanin. This results in a solid, stable golden copper tone that stays fiercely rich no matter what the lighting conditions are. Amber eyes are exceptionally rare, found in less than 5% of the world. Because this stable golden coloration is super common in predatory animals like wolves and eagles, we humans subconsciously associate it with alertness and intense confidence. Evolutionary researchers actually suggest that amber eyes spread less for functional light adaptation and more because this commanding look provided subtle social advantages and really drove mate preference. So, what does this all mean? What's the ultimate biological takeaway here? Well, the crucial point is that your exact eye color is not random. It fundamentally dictates your biological vulnerability to UV radiation over your entire lifetime. If you have extreme or high melanin, like black or blonde eyes, you've got maximum built-in protection. Hazel and green, they give you a solid medium shield. But if you have blue or gray eyes with near zero melanin, you are highly vulnerable to solar damage. Proactive UV protection is biologically essential for you, for sure. When you look in the mirror tomorrow morning, I want you to remember this primary medical takeaway. You're not just seeing a pretty color. You're seeing thousands of years of survival. You're seeing adaptation and an incredible genetic lottery. Your irises are quite literally a living map documenting exactly how your specific ancestors adapted to conquer the wild lighting conditions of early Earth. I'm really curious about the genetic makeup of our audience today. What evolutionary survival tool are you carrying? Drop your exact eye color in the comments below right now. Let's see which genetic adaptation dominates our community here. And hey, if this explainer helped you understand your own biology just a little bit better, make sure to like and subscribe because there is so much more coming your way. Let's move to something else and see how this builds. We've seen how eye color evolved to protect us, but what happens when the human body's fundamental biological rule of symmetry just breaks completely? I'm talking about heterochromia. This is a fascinating condition affecting less than 1% of the population, where a person is born with two completely differently colored eyes. It happens when minor genetic mutations, or a wild process called mosaicism, disrupts the early developmental symmetry of melanin distribution. It completely shatters the visual symmetry we subconsciously expect to see when we look at a human face, which leaves us with a massive question for our next deep dive. Are genetic anomalies like heterochromia just a simple glitch in our biological code, or are we looking at the very beginning of our next evolutionary leap? We'll decode that mystery next time.